Let's look at the first example. Find the power observed by the dependent source in the circuit. The dependent source is over here. And something that I want to point out before we talk about how to solve the problem is the notation. And that 2000 is to match the standard unit that we have for the problem. And in this problem, if we use the units of volts, kilo ohm, and a milliamp, if that's the case, this 2000 IX just become 2 IX. And if we just use these units, that 2000 over there is to match the kilo ohm. If we use this 10K as 10 in the calculation, and this 2000 IX will be 2 IX in the calculation. So we're going to calculate the power absorbed by an element. So we already learned how to calculate power for observed by any element. If we know the voltage on that and also the current going through that element, we'll be able to calculate its power. And when we calculate the power observed by an element, we use a passive sign convention. So these are some basic information that we learned. Passive sign convention. And we also learned KCL and KVL. These are the basic laws for circuit analysis. KCL that will help us to find some current information, and a KVL that will help us to calculate some voltage information. And sometimes we also use the definitions. Use definition of voltage that will help you to find a voltage, right? So we already have practice on these basic concepts already. So let's look at how we solve this problem. So the voltage, let's assume that this voltage here is V, and the current going through that, since this is a single loop circuit, and the current going through any elements, there will be Ix. So we already know that this current going through this element is Ix, right? And we don't know the voltage, but a voltage is 2000 Ix. So we know that the voltage here is equal to 2 Ix. The current going through it is Ix. So let me just call this the current I then. So the current that is equal to Ix. So it looks like if I want to calculate the power, I just need to find out what Ix is, right? I need to set up an equation that will conclude Ix. Since this is a single loop circuit, we can write a KVL equation. Say apply KVL to the loop. So KVL tells us that the voltage drop following any closed loop adds up to 0. So let's just say I'm going to start from from this dependent source. The first voltage drop, I'm going to follow in this direction. This is my loop. The first element, the first voltage drop, which is a 2Ix. The second voltage drop on this 10K resistor, that is a 10 times Ix. The next voltage drop on this 6K, that is 6Ix. The voltage drop on this 20 volt power source, that is increased. So we have a minus 20. And followed by 4K plus 4 times Ix. There's a voltage drop of 60, sorry, plus 60. Then there's a voltage drop of 10 Ix, which is equal to 0. So we can solve for Ix from this equation. So we have a 2, 10, 12, 18, 22, 32 Ix. So 32 Ix plus 40 is equal to 0. So we find Ix. So that is a negative 5/4 milliamp. Remember, we are using the unit set like that.
Professor, just a little curious, why did you make the 2000 Ix into 2 Ix?
This is a voltage source, right? Although it's a dependent voltage source. What is the unit for a voltage source? That is volt, right? And as 2000 is to match the resistance, because in this problem, and all the resistance use a value of a kilo ohm. This 2, you can see the 2000 Ix as a 2K Ix. This 2K is similar to the resistance in the problem. You see what I mean? Since I'm using kilo ohm as the best unit in this problem, so that I only need to use 2, I dropped all the Ks. And if I see a resistor, that will be kilo ohm. If I see a current, that will be milliamp. If I see a voltage, that will be a standard volt. Does it make sense?
Yeah, I get it now. I just realized the units. My bad.
Okay. So now we find the current, then we can calculate the power absorbed by using passive sign convention. And the power P that is equal to V times I. And V we already know that is 2Ix. And the current which is Ix. So that'll become 2Ix squared, right? 2 times Ix squared. Ix is negative 5/4 squared. So that will give us 25/8. What is the unit for power?
Watts, or in this case, kilowatts.
What is it? Think about
It's
it.
watts.
So what?
Watts, yeah, watts. But would it be kilowatts in this case?
No,
about
because
it.
you have
What-
kilo ohm and milliamp.
Oh, I see. Yep.
Yeah. What will be the unit for power? Look, I have a volt, and what is the unit for current?
Milliamp.
Yeah. What will be the unit for power? This is a power, and we said it's equal to V times I.
Milliwatts.
Yeah,
Watts,
this is a milliwatts. The
milliwatts.
standard unit the standard unit is a volt, amp, and a watt, right? Now we are using milliamp, so the 1 watt is, so the watt should be equal to this volt times milliamp. That will give us milliwatts.
Milliwatts.
Remember, so this is a place that you need to pay attention. But other than that, everything else is pretty straightforward. All right.
Professor, I have
yes.
a question. So we're only choosing the dependent source 2ix just because it has the unknown there. Is that what we're solving? We don't include the other ones, I guess.
2Ix is given here.
Okay.
This is our 2Ix, which is the voltage on this voltage source.
Got it.
Professor,
Yes.
if we answer it in terms of like say something, because I don't know, sometimes it's, or I don't know, I find myself in situations where I'd rather work in just like amps instead of milliamps, like for some reason. And if we answered that in terms of watts, it would still be correct, right?
Then you have a different number. So you have like this number 25/8 times 10 to the power -3 if you use the standard
Right.
unit. That's fine.
Okay.
If you use a standard unit and over here, 4K, you need to write it as 4,000 ohm, and 10K will be 10,000 ohm if you use a standard unit. So if I use this unit and all the numbers in the calculation are very small, if you use a standard unit and the numbers that you carry out through the whole calculation, you will see big
Right.
numbers.
Professor,
Okay, thank you.
why was 2000 amps converted to 2 kiloamps if we're trying to work with milliamps?
Milliamp and a kilo ohm and a volts, they are compatible. So look at Ohm's law. So the Ohm's law tells us that the voltage drop on the resistor that is equal to resistor value times current I, right? If we use a standard unit, and this will be volts and ohm and amp, right? So they need to be compatible. So if I give you the current of a milliamp and a kilo ohm times milliamp, you have 1,000 times 10 to the power -3. The unit for voltage that is also volt. So you can use this unit set to describe this three.
Oh yeah, I understand that. But in the example you gave us, you're using 2 kiloamps instead of milliamps
2 kilo
at the dependent voltage source.
Dependent
Oh wait, never mind. That's
source.
voltage. Never mind. Sorry about that.
Yeah, this is a voltage unit. After the 2,000 times Ix, that will give you a voltage unit. This is a voltage source. All right, any other questions? All right, let's look at the second example. In the second example, we're gonna find a VS in the network. VS is voltage. This current source. This is called a dependent current source. and which is similar to the problem that we saw just now. And we're going to use the units. This best unit, I'm going to use milliamp, kilo ohm, and volts as my unit sets. So in that case, the current over here, it'll become 2Vx. I can drop all the Ks. And also milliamp, and I will drop the units milliamp, kilo ohm, and that K as well. So this K over here is also used to match the units. So with that said, let's look at how we can solve this problem.
Professor, just to clarify, by you dropping the K, now we're just looking at it as volts, and with the ohms, and that, would that be still MA, or would that be?
So the units here means 2Vx milliamp, because I'm using milliamp. And if you drop that K, that will become milliamp. If you keep that K, that is amp.
Oh,
Does that make sense?
yeah, that makes sense. Thank you.
Yeah, if you keep the K, that is amp, because that is the current unit, that is standard unit. And I said I'm going to drop the K so that it becomes milliamp, right? Because I divided by 1,000, and I dropped that 1,000. It means that if I use a milliamp, it means that the number in front of it should be 1,000 times larger. So that number times 1,000, that becomes 2Vx, right? All right. To find the voltage drop, this is a single node pair circuit, right? We have one pair of node, and all the other branches are in parallel. And in this case, we can use the conclusion that we get to calculate to find the current in these two branches, right? So one branch, two branch, and a three branch, and four branches are connected to this node pair. Let's call this node A. If I apply KCL to node A, I'll be write a nodal equation. So we haven't learned nodal equation, then I will be able to write one equation, right? So let's write the equation. Let's count the current goes into a node as positive. So for this branch, I'm looking at this branch. So that is the current goes in there, and the current value is 2Vx. And the second branch is the current over here, but I don't really know the current over there. Let's just temporarily call this current I1. The next one is the current in this branch, but I don't know what that current is, but I'm going to call it I2. And the last one is the current 2 milliamp that goes in, that is equal to 0. So it looks like I have a lot of unknowns. I have 3 unknowns need to address. But Vx over here is a pretty straightforward. Vx is related to I2, because Vx defines the voltage on this resistor, 1K resistor, and this 2K. These two resistors, they are in series, right? So one connected to the other, and there's nothing else in between. So we can use Ohm's law to find a relationship between Vx and I2. So we find I2 is equal to Vx divided by 1, but in the reverse sign, right? So that is a negative Vx divided by 1K. So we have one more equation. We need another one. The other one needs to help us to find a relationship between I1 and Vx. We cannot find a direct relationship between I1 and Vx, but I do know the relationship between I1 and I2. These two branches, they're in parallel. So it means the voltage between node A and node B, that should be the same. The voltage between node A and B from this branch with a 1K resistor, that is a negative, if I calculate VAB. For that branch, it's a negative I1 times 1K, right? And for this branch with 2 resistors, and the voltage drop on this 1K resistor is Vx, and they have the same value, so they are in series. So I know that the voltage drop on the top 1K resistor is also Vx. That is equal to 2Vx. So now we find all the relationship between I1, I2, and Vx. So I2 is equal to negative Vx, and I1 is equal to negative 2Vx. We submit 2 and 3 into the first equation. We can have 2Vx plus I1. I1 is a negative 2Vx. Plus I2. I2 is equal to negative Vx plus 2, that is equal to 0. So we can find a Vx is equal to 2. So what is the unit? 2 volts, right?
2 volts. Yeah.
Yeah, after we find a Vx is equal to 2 volt, we can calculate a Vs. Vs is actually VAB, right? So we just call it a VAB just now, and that is equal to Vs. That is the voltage between node A and B. VAB, we already know that VAB is equal to 2Vx from here, from the equation about equation 3. That is equal to 2Vx, so that will give us 4 volts. This is how we solve this problem. So we give one example, which is single loop problem. And this is the second example, this is a single node pair problem. So now you see that for every different type of problems, we will have at least one example. Let's look at the next example.
Oh, I have a question for that last
Go
one.
ahead.
Just can you verify how we got I2? I just got kind of lost on that one. I understand everything else, but I2.
I2 is over here. I2 is the current of there. And we find I2 for this resistor, 2K resistor, this 1K, these two 1K resistors, they are in series, right? So the current going through them should be the same. The current going through the second 1K resistor, the current going through that, if we say this is I3, and you can find I3 by using Ohm's law of Vx divided by 1, right?
Yes. Oh, it's the opposite. Got it.
Yeah, I2 is opposite. All right, let's look at next example. In the next example, we're going to find our AB in the network. So we learned 2 different ways to solve this problem, right? So if you can see the connection right away, then everything will be easy. And if you cannot see the connection, then I would recommend you to draw the equivalent circuit diagram. Assume that I cannot see the connection, I will draw the circuit diagram. I will start with the node that's already given. So this is node A. There's nothing between that node A and this dot. So this is my node A, right? There's nothing between this node B and this node. I will call this B's. Then I will start to draw the equivalent circuit. And this equivalent circuit, I'm looking for the connection between A and B. The first I'm going to look at are there direct connections between A and B with one element. I do see this, right? So between A and B, there is a one resistor, 6K. I'm going to first draw this 6K over there. And between A and B, there are no other direct connections. And all the other connections has to go through this node C. Has to go through this node C over here. Between A and C, I have a one resistor, which is 5K. And between C and B, I have all the other branches, 1, 2, 3, and 4, right? There are 4 branches. The first branch is with the 3K. The second branch is 3K. The third branch is 4K. The last branch is 4 and 8 in series. 4 and 8. Oops. Not sure what happened. Why occasionally it give me a long stroke. So this is 4 and this is 8.
Well, can we do that one as like 12 as well, right?
Yeah,
Okay.
yeah, you can do that. So I'm drawing the equivalent circuit, so I'm trying to keep everything the same as what's in the original circuit. So now we can see the connection. We can simplify the circuit to find RAB. RAB. So look at RAB. This is 6. It's in parallel with the whole rest of the circuit, right? So this is 6. It's in parallel with the whole thing of the rest. And for the rest of the network, we have 5 in series with all the rest. We have 3 in parallel with the 3, in parallel with the 4, in parallel with the 4 and 8 in series. So this is how we find RAB, right? So let's simplify it. So 6 in parallel with, so we have 12 in parallel with the 4, that is 3, right? 12 and 4.
Yes, because 48 divided by 16.
Yeah, so that is 3. So I have 3 in parallel with 3, then in parallel with 3. So 3 in parallel with 3, that is 1.5. In parallel with 3, that is 1, right?
Yes.
So 5 plus 1. So 6 in parallel with 6, so that gives us a 3, and the unit is a kilo ohm. So this is a way that I would recommend for you to solve the problem. Draw the equivalent circuit before you simplified it. So some students are more confident. They feel like I can see the connection right away. I don't want to draw the equivalent circuit. I would just do it a block by block. But even if you do it a block by block, you still need to draw the equivalent circuit diagram. Say, I'm gonna just simplify this block first. I'm gonna call this a block 1. After you simplify the block 1, you will still need to draw the equivalent circuit. Then you simplified it in a second step before you can find an RAB. All right. So let's look at the next problem.
Professor, sorry, dumb question. Why do you do the calculation like that? The 12 times 4 over 12 plus 4?
Oh, this is how we simplify the resistor 4 in parallel with the 12. You know that if you have two resistors in parallel, if they are of the same value, the total resistance will be half of the resistor. So it means that if you have a 3 in parallel with 3, so the value will be half of 3. If you have a 3 in parallel, so the value will be 1/3 of the resistor. So actually 3 in parallel with 3 in parallel with 3, you should get a 1. So that is just a special case. So actually, you can derive the conclusion pretty easily. Think of you have 3 resistors like that, and each resistor have a value of R, R, and R. And what is the total resistance? We know the conclusion. The summation of the R total, that should be equal to the summation of each of them, right? Because they are all the same, so you have a 3 times of 1 over R. That's how you find RT that is equal to 1/3 of R. So that's why we said if we have a 3K resistor in parallel, you should get a value of 1. Right. Let's look at the last example. In this example, again, we're going to find RAB in the circuit. I would just assume that I cannot see the connection right away, and I would do the labeling, right? So I will try to let you do the labeling together with me. So we started from the node that's given, A, and what it will be this node. Can you see my mouse, by the way?
The mouse, no, only when you write.
Oh, that's interesting. How can I let you guys see my mouse? Can you see my mouse now?
Yeah, now you can. Yeah.
Oh, it looks like
Now I
I need
can,
to use I cannot use a pen to let you see, but I can definitely use my mouse. What is the name of this node?
Would that be A?
Yeah, this is A. And how about this node here?
A as well.
Yeah, because there is nothing in here, right? And what is this node?
B.
Yeah, that's a B. So let's draw the equivalent circuit. And between A and B, are there any direct connections?
There's two, isn't there? What about the ones on the corner, left and
Between
right?
A and B, I don't see any direct connections. It means there is only one resistor between A and B.
Oh, okay.
And it looks like it has to go through any other elements. Think of that we are trying to find a connection. We started from A, I'm looking for B. So over here, I have to go through, when I go through this resistor, I see a new node. And if I take this path, go through these two resistors, I see this new node. So it looks like if I want to go to B, I can either go from the left-hand side through this node C, or go from the right-hand side, then I will see this node D. Right? So I don't have any direct connections between A and B, but there's a one node. If I go through this node C or go through this node D, I will be able to find some connections. Then we want to ask ourselves, what's between A and C? Between A and C here, A and C here. I have two branches, right? So between A and C, I have two branches. One is a 4K, the other one is a 2 and 2 in series. So 2 and 2 in series, and this is 4. So between C and B, how many branches? Let me just chop them off so that I will remember which one that I counted already. So between C and B, there is only one branch. It goes from here, right? So it follows one path from C to B here. So between C and B, there are two resistors in series. The one is a 2, the other one is a 2. So we finished everything between A and B through this node C. Then the rest, we need to find the connection between A and D, then from D to B. Between A and D, how many branches do we have? 1 and 2, right? We have 2 branches. And one branch is a 4K. And the other branch has a 2K and a 2K in series. And between D and B, how many branches do we have? We have one path that goes through this 2K and 2K, right? That's it. Now we find our equivalent circuit.
Professor,
Yes.
if we see right now like that it's the same exact thing, it's just mirrored, and so then therefore C and D are parallel, can we just find C or D and then
Yeah.
like say it as parallel? Okay.
Yeah. Cool. So they are you find this part and the rest, they are the same, but they are in parallel. This is two big blocks. They are in parallel, right? So if we can find block 1, we know block 2. So the resistance for block 1 that is equal to, and we have this 4 and in parallel with 2 and 2 in series,
Equals
then
2,
in series with 2 and 2, right?
6.
So that will give us a 6 kilo ohm. Then our AB is equal to, this block 1 is a 6, and the other block 2 is also 6. 6 in parallel with 6, so that will give us a 3K. So this is how we solve this problem. All right, we finished all the practice examples. So these are the problems that you need to submit as well. So don't forget to submit to the practice problems for this section. And if you really want to practice more, you can find some other similar problem from the back of textbook to practice. But use some time to study for the next topic. You don't, if you feel like you are after this practice together with me, you feel pretty confident with this topic, and use the time to study for the next topic. All right. Any questions for today?
Yeah, Professor, I have a question for the second example.
Second example.
If you could just go over really quickly how you got the voltage from A to B is equal to just -1 times I1.
I see. So the voltage, I find that part by using Ohm's law on this branch.
So it's not, but since all the branches are connected technically between node A and node B, why are you just doing it through the middle branch?
You can do it from any branch. So the voltage is the same voltage for all these different branches.
I see, okay, okay.
Yeah, so the voltage is defined between nodes because this is a one node pair. So if you do it following any branch, that will be the same because they are all the branches are in parallel. So the voltage, for example, if I ask you for the voltage here, and you should know this voltage on here is also equal to Vs. It's the same voltage here. The same voltage everywhere for between this node pair.
Thank you.
Any other questions?
So, Professor, for question 4, how did you know how to draw that the circuit or redraw the circuit?
So when I redraw the circuit, I'm just following the ways to find the connection between A and B. So that is the main idea. Just think of that you have a current flow from A to B. I will draw the equivalent circuit. Assume that the current flow comes to the node A, will come to here. And if you want to continue flow, it will flow from here and here to get to C, then back to B. Or you can flow from here to here, then from A to D, then to B. Then that will be everything.
Oh, okay, thank you.
Professor, can you do question number 57? That wasn't on the slide, but it was like.
Yeah, of course. So let's look at that problem. So we're going to find the current over here. So whenever we want to find a current, that will remind us to use the KCL by looking at some node that will be able to write the node, write the equation that I can solve for the current, right? So in this problem, I have this node over here that are connected with this unknown. So let's call this node A. I'm going to apply KCL to this node. And count all the algebraic summation of the current goes into the nodes is 0. We have this branch goes into the node, which is IO. And this branch, the current goes into a node. I'm not quite sure. So I'm just call it I1 then. And the current in this branch that is leaving, so -5. And the current 3Vx that is coming in plus 3Vx that is equal to 0. So in this equation, how many unknowns do I have? 3 unknowns, right? And the 3 unknowns imply that I need 3 equations to solve. Where do I find the second equation? And I want to find a relationship between all of them. So by looking at how I define I1, I can find a relationship between I1 and Vx. That's perfect. I'm going to use Ohm's law to find a relationship with that. So Ohm's law. By looking at here, the voltage of Vx is equal to the current I1 times the resistance, that is 4, right? So we have one additional equation. I need another equation so that I can so that I can solve the whole thing. Where do I find the other equation? The relationship between these 2 branches. If we look at these 2 branches, they are in parallel, right? So these 2 branches, and one branch has a resistance of 6, and the other branch has a resistor of 8 and 4. The current in this branch is IO. The current in this branch is I1, right? So we know that voltage between these 2 nodes should be the same. the voltage between these two nodes, if we calculate by using the left branch, that'll be 6 times IO. And if we calculate the voltage on the second branch, that'll be 8 plus 4 times I1, right? So we can do it that way. There is another way we can do this. So that is a 6. So this is the first way. The second way to do it is by using the relationship between the voltage drops. So on this, because this is 4K and this not 4K, this 4 ohm resistor and this 8 ohm resistor, they are in series. The voltage on this 4 ohm resistor is the Vx, implies the voltage on this 8 ohm resistor is 2 Vx. So the total voltage drop, that is a 3 Vx. So you can use either of these two relationships that will be able to give you the third equation to use. So let's call this equation 1, this equation 2, and this equation 3. And you have a different way to write equation 3. Now you have these 3 equations, you will be able to solve the problem.
Could you repeat how you got 3Vx?
The way we, so the, just now we are, for this equation, we are trying to find the voltage drop from this node B to node A. The VB, so this is the VBA basically. So if we find a VBA, we can use the definition, the voltage counter voltage drop from B to A. The first voltage drop on this 8 ohm, that is 2 Vx, plus the voltage drop on this 4 ohm, that is 1 Vx. That's how we get a 3 Vx.
Thank you.
Then we can put this into the first equation. So we have IO plus I1 is equal to, from the second equation, I1 is equal to 1/4 of Vx plus, and from the third equation, we find 3 Vx is equal to 6 IO. We find a Vx is equal to 2 IO. And we put this back into the second equation. Vx is equal to 2 IO, so that will give us I1 is equal to half IO. So we put over here half IO minus 5 plus 3 Vx. Vx is equal to 2 IO, so that is 6 V. Yeah, that's a 6 IO. That is equal to 0. So now we can solve IO. So what do we have? We have a 7.5 IO. No, sorry. This is, oh yeah, 7.5 IO is equal to 5. So that is if we that is how much? 2 over 3. 2 over 5. 2 over 3. Sorry. 2 over 3. The unit is M. So this is how we solve this problem. All right. Anything else? Yeah, now you can see that for all the, no matter how they change the problems, the way to solve them, they are more or less the same. If you are looking for a current, check the KCL equation and look at how many unknowns that you have there. That will tell you how many additional equations you will need, and then use the unknowns to find a relationship between the unknowns. So in the problem, that will tell you like you have multiple different ways to find the relationship between them. As long as you have 3 independent, so in this problem, because where you have 3 unknowns, as long as you have 3 independent equations, you will be able to solve them.
So Professor, we got 4x is equal to 4I1 because it's going downwards. So that's how we got the 4 from there, right? Because it's going into node A.
Are you talking about the second equation?
Yeah.
The second equation comes from the Ohm's law. The Ohm's law is applied on this 4 ohm resistor. So the voltage drop on this 4 ohm resistor is the Vx, and the current going through that is I1. So Vx is equal to the 4 ohm times the current I1.